Hey guys, sorry about the connectivity issues we had today. Because of that, I wanted to make this video as a resource just in case you needed it. Some of these concepts might be new or confusing or just might need a refresher. So I want to look at the important questions. The basic equations are pretty easy with the replacement set or even with just the order of operations. I think you can work with all of them. You guys seem to be fine with that. These are the ones, these different solutions and different types of equations and the word problems I want to look at real fast. So for a problem like this, I'm going to follow the steps in the order of operations. I'm going to simplify what's in the parentheses on both sides of the equation right here first. So I'm going to bring down this 4n minus, and 12 plus 2 in parentheses is 14. I don't need parentheses anymore now because it's just minus that total. So it's 4n minus 14 on the left side. And it's equal to, well, in this parentheses, 6 minus 2 is 4. This says n parentheses 4, that's multiplication, n times 4. We don't write n times 4. The commutative property of multiplication says you can change the order. We always write the coefficient before the variable. So we wouldn't write n4 or n times 4. We would write 4n minus 9. Now I take a look at this equation and I say, well, look, the variable value with the coefficient on each side of the equation is the same. Therefore, whatever n is, 4 times that number on the left and 4 times that same number on the right will be the same value. So that being said, whatever that value is, if I subtract 14 from it on the left, the same value subtracted 9 on the right could never be equal. It's impossible. Take any number for n, let's say 5. 4 times 5 is 20. 20 minus 14 is 6. 4 times 5 is still 20. 20 minus 9 is not 6, it's 11. So no matter what you put in for n here, it's impossible to get the equation to be equal because the variable coefficients on both sides are the same, but the constants are different. We're subtracting a different number from the same total. So therefore, there is no solution to this. There are no possible values you can put in for the variable that are going to make this equation true. T-I-O-N. Very sloppy with the mouse, I'm sorry. There's actually a symbol for this too. If you prefer to use the symbol, you'll see the symbol. You should have seen the symbol before. It's a 0 with a slash through it. That's the no solution symbol. Okay, that's one of the specific and special types of equation solutions. The next one I want to look at, I'm going to skip through all this real fast. Oop. Next one to look at is this one. A lot of stuff going on here, a lot of different steps to do. We'll do them one at a time because we're going to try not to get overwhelmed by it. Let's do what's in the parenthesis here because that's the first thing in the order of operations. 5 plus 8 divided by 4. I'm going to divide before I add in the parentheses. So 8 divided by 4 is 2, and then 5 plus 2 is 7. So this is 7 plus 3k is equal to, well, on this side, I can't do it in the parentheses because they're not like terms. So I'm going to use the distributive property, multiply to 3 times the k, and multiply to 3 times the 32, which is 96, minus the 89. So now, on my left-hand side, I have nothing to do. 7 plus 3k can just come down just like it is because there's nothing to simplify. 7 plus 3k is equal to the right-hand side. I have some like terms to combine, 96 minus 89. Use the associative property, group them, they're like terms, subtract them. So the 3k stays the way it is, but 96 minus 89 is 7. Well, because of the commutative property of addition, these two sides are equal. 7 plus 3k and 3k plus 7 are the same thing. Whatever 3k is on the left, 3k on the right is the same And if I add the same number on both sides, if I add this 7, it's still going to be the same. There is not a single number, a real number. There is no real number you can come up with for k that will make this equation not work. Therefore, the solution to this is, this I'm going to type. The solution to this is all numbers. Or you could say all real numbers. We'll learn there are numbers that are not real later. Or they call this an identity equation. Identity means that all solutions will work. Okay? That's why this is a special solution. This equation will always be true no matter what value you put in for k. If you say k equals 5, well, yeah, it does equal 5. It also equals 6 and 7 and 4 and 2 and 3.6 and negative 27.9. And whatever you come up with will work to this equation. Okay? I'm going to move on real fast to the word problem. So those are 2 examples of that. Actually, I'll put this example up. If you want to pause it and work it out and see what you get, that's fine. You can pause the video, work this out if you want to practice it. Same thing here. If you want to pause the video, work it out, see what you get. Okay? All right, if you did pause, now you're unpaused, now we're back. So we have some word problems. The word problems are going to make us write equations. So Delilah pays $16 per month for a gym membership. No matter what, 16 bucks a month. In addition, she pays $2 per Pilates class. $2 per Pilates class. That means each. Write and solve an equation to find the total amount Delilah spent this month if she took 12 Pilates classes. So she has to pay her monthly membership. The monthly membership, I'm going to text this instead of write it. The monthly membership is $16. Let's change that color too. Let's change it to nice and bold red. Monthly membership is $16. Plus, she has to pay for her Pilates classes. Her Pilates classes are $2 per class. I'm going to call that P for Pilates. And if you take that $16 membership and the $2 per Pilates class, that gives you her total cost. I'll call that C for cost for the month. You could call it M for the month if you want. That's up to you. And now they give me a value to put in for the Pilates classes. They tell me that there are 12 Pilates classes. So I will substitute in and replace that. So 16 plus 2 times 12 will equal the total cost for Delilah at the gym. And now I will do the multiplication first. 2 times 12 is 24. So it's 16 plus 24 is equal to the cost. And that tells me that her cost is $40. That month it costs her $40 based on the $16 per month individual membership, and then the $2 for each class for her 12 classes. Okay? And last but not least, I want to give you one more word problem. If I can click there. Let's see, let me erase all this stuff. And go ahead to the next word problem. Ignore all the answers. Pay attention to the question. An online catalog's price for a jacket is $42. The company also charges $9.25 for a shipping per order. Write and solve an equation to find the total cost in order for 6 jackets. So I'm going to write the equation first. I'm going to do it in text right here. It's $42 per jacket. Plus, every order has a shipping charge of $9.25. No matter how many jackets it is. It doesn't say $9.25 for each jacket. It says $9.25 for an order. So if you order 1 jacket, it's $9.25 for shipping. If you order 10 jackets, it's $9.25 for shipping. And that will equal the total cost. All right, well, let's take a look at these. C equals 42 plus 9.25, no good. C equals 9.25, J plus 42. No, that's 9.25 times the number of jackets, but that's shipping. That's not the cost of the jacket. C equals 42 minus 9.25 in parentheses, no way. 42J plus 9.25. There's my good looking answer right there. It looks like my answer is going to be D. And if I click it, you'll find out the answer is D, because you would take 6 jackets and put it in for J and multiply it by 42, add 925. Hopefully that helped. I don't know if you needed that extra little reminder how to do these, but if you did, that's what this video is for. I'll see you tomorrow.